Welcome back to the fifth section, chapter 2. In this section, we're going to be looking at linear inequalities in two variables. So we're going to have the inequalities that will be both x and y. We'll be looking at graphing mostly. We solved a little bit before, but we're going to be graphing. This isn't the graphing that we did at the beginning of the chapter with inequalities, because we only had one variable and that was on a number line. This graphing is going to be on an actual coordinate plane. So let's look at our learning targets. I can graph linear inequalities on the coordinate plane, and I can solve problems using linear inequalities. So first, looking at graphing linear inequalities, what's different, what's the same? The best thing is that it's basically the same as graphing a line. It is almost identical. However, there are two differences from just graphing equations. The first one is the line itself, and we'll talk about that in a second. And the second one is shading. We have to shade. Just like on a number line, we have to shade one way or the other. On a graph, we have to shade one way or the other. So, back to the line. Remember, we have different dots for the different symbols. So for less than or greater than, we have an open dot, an open circle. It's one that's not filled in. Well, when we're graphing, we have an open line. What would an open line look like? Something that's not filled in. That would be a dotted line. And then for the or equals to, we had a closed dot, a closed circle, and so we use a closed line. No, that's a clothes line. We use a closed line, which would just be a solid line. Now, a pro tip here, when you're graphing these, use pencil. Even if you generally do your math in pen because you're one of those crazy people that likes doing that, use pencil. Because when you're graphing these, a lot of times you figure out, okay, the line goes here, zoop, and you make the line. And then the thought on whether or not it should be solid or dotted is an afterthought. Well, the cool thing about the pencil is down here, we have the business end of the pencil. That's the end you use to make your line, to do your math, things like that. Now, I don't know if you've noticed this. I just recently discovered if you go to the other end of the pencil, up here, there's this cool little tool. I'm not sure what its intended purpose is, but it is a dotted line maker. It can take a solid line and it can change it into a dotted line really, really easily. With pens don't have that tool. On my chalkboard, I have to have a supplementary tool because my chalk doesn't even have that. So your pencils come with a built-in dotted line maker, and that is absolutely awesome. So let's look at graphing these linear inequalities. If we have something like y is less than or equal to 2, hey, look, y equals something. It's horizontal. Same thing with y is less than or equal to something. This is going to be a horizontal line. So we get our graph. We can put our dot at 2. Then we can make our line. It's closed, so it's solid. And then shade. Where is y less than 2? The or equal to is on the line itself. So we're just looking where is it less than 2. Well, in this case, it's y is less than 2 down here, so we can shade down there. A lot of times, I would plug in a point to figure out where it works. We can plug in the origin. It's always watching you, and it's easy to plug in. So that's 0, 0. Is 0 less than 2? Yes, it is, so that works. How about if we have something like y is greater than or equal to x minus 3? So this is slope-intercept form already. We have a y-intercept of negative 3 and a slope of 1. So we can start out with our y-intercept of negative 3. And the slope of 1, we're going to go up 1 over 1, up 1 over 1, up 1 over 1. The line's a solid line. And then we need to shade. So plug in a point. If we plug in the point 0, 0, is 0 bigger than 0 minus 3, is 0 bigger than negative 3? Yes, 0 is bigger than every negative number. So we would shade above the line. If we had plugged in a number and it didn't work, we'd shade the other side. So how about ones where we have to do a little bit of work? This one, we have 3x plus 2y is greater than 12. How did we graph these the other day? Using intercepts. In fact, the directions for this problem says use intercepts to graph. So if we have our graph, if x equals 0, 2y is bigger than 12, so 2y equals 12. That's where the line's going to go. So y would equal 6. So we have a point there. And then if y equals 0, 3x equals 12, so x equals 4. Oh, the line is dotted going across. There's my dot. It's in the wrong order. Anyway, the line is dotted because it's not or equals to. This is where that dotted line maker can come in handy if you accidentally made a solid line first. And we need to plug in a point. Let's plug in 0, 0. Is 0 plus 0 bigger than 12? No, it is not. Plug in a point on the other side. Something not close to the line. Like plug in 10, 10. Is 30 plus 20 bigger than 12? Yes, so we shade the side that would include 10, 10. And how about one where we actually have to do some solving? So a couple ways of doing this. We could multiply by 2 to get 6x minus 2y is greater than or equal to 8 and solve from there. I distributed the 1/2 because I can see that both 6x and negative 2y, I can multiply by 1/2 and it's actually still pleasant. So that would get us 3x minus y is greater than or equal to 4. Subtract the 3x over. So negative y is greater than or equal to negative 3x plus 4. Multiply or divide by the negative 1, which when you do that, it flips the sign. And so y is less than or equal to 3x minus 4. Now we can graph this one. Y-intercept is at negative 4. The slope is 3, so we can go up 3 over 1. Up 3 over 1. We can connect the dots with a line, a solid closed line. And then graph. If we plug in 0, 0, is 0 less than 0 minus 4, 0 less than negative 4? No, 0 is bigger than a negative. We can plug another point. We could go way over here, or just go straight down. Keep x 0. Is negative 6 less than 0 minus 4? Yes, that one does work. And so we can fill it in. I know a lot of people have the habit of, oh, I'm just going to fill if it's less than, I fill in below. If it's greater than, I fill in above. That does not always work, especially if it's in this form. If you put it in slope-intercept form, it's generally right. But when you're using intercepts, it doesn't always work. If one of these was negative, it would have flipped it on us. And so that's graphing linear inequalities. We're also going to look at using them to solve some problems. And so if we have a word problem, I have a graph here already because I forgot to fade it in. Let's see, the senior class sells hamburgers and hot dogs at a football game and makes a profit of $1.75 on each hamburger and $1.25 on each hot dog. The class would like a profit of at least $280. Let X represent the number of hamburgers and Y represent the number of hot dogs sold. Write and graph an inequality for the profit that the senior class wants to make. So we want to write an inequality for this. And so this is all profit, so we don't have to worry about cost and revenue and things like that. It's just all profit. We just have to add it together. And so they make $1.75 in each hamburger. How would we put that in an equation? I know some people tend to struggle with this. There's a really easy way of setting these equations up. So $1.75 in each hamburger. Well, if they sold one hamburger, how much did they make? $1.75. How about if they sold 10 hamburgers? $17.50. How do we figure that out? This times the number of hamburgers. 175 times X. Same thing for the hot dogs. 125 times Y. We add that together, and we get the equation. 175X plus 125Y is greater than or equal to 280. And so setting them up in general or standard form for this type of question is a lot easier than trying to find a slope and doing that kind of thing. From here, we can find some intercepts. If x equals 0, y equals 224, because we can divide by 125. And if y equals 0, x equals 160, because we'll divide by 175. We can graph those 2 points. Now here, being that the graph is a lot more zoomed out, that point might not be exactly where it's supposed to go. It should be close, though. We can connect the 2 dots. In this case, you don't really need lines because you're not going to sell, or you don't need arrows because you're not going to sell negative hot dogs or negative hamburgers. So you can literally just connect the 2 dots. And we need to shade. Where are we going to shade? Well, let's think about it. If they don't sell anything, are they going to make the $280 they need? No. If they sell a whole bunch of stuff, will they? Yes. And so this one is shaded out here. And now, second part of the question, if they sell 100 hot dogs and 50 hamburgers, will they meet their goal? Here, notice the 100 hot dogs and hamburgers got switched in their order. Well, on the graph, we can find 50, 100. That would be 50 hamburgers, 100 hot dogs. It's right about there. Is that in the shaded region? No, it's not. What if it were close? Well, if it were close, and even if it's not, you can always plug it in. 175 times 50 plus 125 times 100 equals 280. We can multiply these guys out to get 8750 plus 125 is greater than or equal to 280. And this is really a question. Is it greater than or equal to 280? When we add it together, 21250 is not bigger than 280, so that would be false. And no, they did not meet their goal, which is something that we can see from the graph in this case. But if it was right here, how close is the graph? I don't know. And so there we would definitely want to plug it in. Anyway, so that is linear inequalities in 2 variables. Graphing. Sometimes you'll have to solve some inequalities for y. Finding the intercepts is the same with equations. Graphing is the same, except for is the line solid or dotted? And then you have to shade on one side or the other. And then setting up problems to solve them. And that would be it.